1,470 light-years from Earth, there is a star that breaks every rule we understand about how stars behave. It flickers, randomly, chaotically, sometimes dimming by 3%, sometimes by 15%, sometimes by 22%. 22%. No star has ever been observed dimming by that much and then returning to normal. The pattern makes no sense. Irregular, asymmetric, different every time, as if something massive is passing in front of it, something structured, something that shouldn't exist. When scientists first saw this in 2015, they checked their instruments, ran the numbers again, because what they were seeing violated everything we know. And then someone said, alien megastructure. Tonight, you're going to discover Tabby's star, the most mysterious object in our galaxy, and why scientists still can't explain it. Because nothing natural should behave like this. 2009. NASA's Kepler Space Telescope monitors 150,000 stars, searching for planets. The data is massive, too much for professionals alone, so NASA releases it to citizen scientists, planet hunters. In 2011, volunteers flagged something wrong. Star KIC 8462852, a normal F-type star, but its light curve looked like nothing they'd seen before. When a planet transits a star, you get a smooth, symmetrical dip, maybe 1%. Jupiter blocks 1% of the sun's light. The biggest exoplanets, 2%. Tabby's star dimmed by 15% in one event, 22% in another. To block 22% of a star's light, you need an object half the diameter of the star, but planets can't get that big. And the transits weren't periodic. They were random, different depths, different shapes, multiple peaks, as if several objects passed in sequence. Astronomer Tabitha Boyajian tested every explanation. Planets? No. Asteroids? No. Cometary fragments? No dust signature. Planetary collision? Debris should dissipate over time. It didn't. In October 2015, she published, "We are unable to find a single explanation." The paper mentioned, almost casually, that the pattern could be consistent with alien megastructures. The world went insane. Within weeks, SETI pointed their telescopes at Tabby's star. They listened for radio signals, artificial transmissions, anything technological. Nothing. Silence. But while SETI listened, other astronomers dug through old data, photographic plates going back a century, and what they found made everything worse. Over the past 100 years, Tabby's star has dimmed by 20%. 20%. No healthy star naturally dims by 20% over a century. Other stars in the same photographs? Constant brightness. Only Tabby's star was fading. Then, in 2017, the star dimmed again, in real time. Astronomers worldwide watched it drop 3%, then recover. This time, they had spectroscopy. They could analyze what was blocking the light. The result? Blue light blocked more than red light. That's consistent with dust, not a solid structure. So, dust? Natural after all? But the 2017 dip was only 3%. The previous dips, 15%, 22%, were too deep for dust clouds. And the century-long dimming? No dust cloud persists for 100 years. Every explanation fits some of the data. Nothing fits all of it. The star appears to have multiple mechanisms causing dimming, as if it's multiple mysteries layered on top of each other. Here's what makes this star truly unsettling. The dips are not completely random. In 2018, machine learning algorithms analyzed the Kepler data, searching for patterns humans missed. They found something. subtle correlations between dip depths and recovery times, patterns in the spacing between events, not strong enough to predict future dips, but strong enough to suggest the events aren't purely random. It's as if something is orchestrating these events, following rules we don't understand. Think about what this means. If it's debris from a collision, it should spread out, dips becoming shallower over time, not happening. If it's comets, we should see periodicity. We don't. If it's dust, it should dissipate. The century-long dimming says it's persisting. One team proposed a ringed planet on an elliptical orbit. The rings create irregular transits. Beautiful theory, except no planet detected through any other method. If it exists, it's enormous and somehow invisible. We're back to the same problem. Everything that explains the small dips fails to explain the large ones. Everything that explains the large dips fails to explain the century dimming. Tabby's star is multiple mysteries layered together, and that's what haunts astronomers. Because in nature, extreme events should have common precursors. Rare phenomena should appear elsewhere in milder forms. But Tabby's star stands alone, 1 out of 150,000, unique. Right now, astronomers worldwide monitor Tabby's star continuously, waiting for the next dip. The latest research focuses on dust models, a massive debris field in complex, chaotic orbits. When clumps align, deep dips. When they spread, the star returns to normal. The century dimming, dust spiraling slowly into the star. It fits most of the data. Most, not all. The 22% dip still requires an implausible amount of material in the exact right configuration. And there's the timing problem. If this is a debris field, it should be young, millions of years old. We just happen to be looking at this star during the exact century when it has this unprecedented activity? The odds are uncomfortable. Scientists keep watching, keep modeling. They've found a few similar candidates, stars with irregular dimming, but nothing as extreme. Tabby's star remains unique, an outlier, 1 out of 150,000. And that uniqueness haunts us, because if something happens once, it should happen elsewhere. But Tabby's star stands alone. 1,470 light-years away, Tabby's star shines. The light reaching us now left that star in the year 554 AD. And in that light is a message we can't decode. The star dims, recovers, dims again, in patterns we can describe but not explain, following rules we can detect but not understand. We've ruled out alien megastructures, probably. The data suggests natural causes. But we haven't explained it, not completely. And until we do, Tabby's star remains what it has always been. A mystery written in starlight. A puzzle we're not sure we want to solve. Because sometimes the most terrifying answer is that there is no answer we can comprehend.